Good morning. We are going to start progression and series from Arun Sharma, level of difficulty 2. The first question we are going to take is question number 21. The sum of the third and the fourth term of an AP is 19. So we can write this as the sum of the third and the fourth term, A3 plus A4 is equals to 19. And that of the first and the seventh term is 22. First and the seventh term is 22. We have to find A9. A9. So we are given two equations. From using these two equations, we can find the value of A first term and D common difference. We can write A3 as A1 plus 2D and A4 as, we can write A1 as just A plus 2D and A4 as A plus 3D equals to 90, which gives us 2A plus 5D equals to 90, and first term is just A plus seventh term A plus 60 equals to 22, which will give us 2A plus 16 equals to 22. We can subtract these two equations. This will get reduced. Minus D equals to 19 minus 22 is minus 3. So D equals to 3. And we can put this D back into any of these equations to get back the value of A. 2A plus 15 equals to 19. 2A equals to 4 equals to 2. So we got D equals to 3 and A equals to 2. Now we want the ninth term. Ninth term will be A plus 8D, which will be nothing but 2 plus 8 into 3, that is 24, which will be 26. The answer will be A. Going on to the next question. How many terms of an AP must be taken for their sum to be equal to 200? You have to find the number of terms that must be taken so that Sn equals to 200. Okay. If the third term is 60 and the difference between the sixth and the first term is 30, third term is 16 and the difference between the sixth and the first term. So how can we write the sixth term? A plus 5D, and we are given the difference between the sixth and the first term is 30. So from here we got 5D equals to 30, so D equals to 6, and we are given A3 equals to 16. A3, how can we write A3? A plus 2D equals to 16. From here we can put the value of D and we can get A equals to 16 minus 12, that is 4. So now we have to find N so that the sum is 200. The formula for Sn is directly N upon 2, 2A plus N minus 1 into D. Sn is given 200, N upon 2, 2 into 4 plus N minus 1 into 6. We can just solve this equation and get an answer. We can take this to here. 400 equals to 8n plus 6n square minus 6n and 6n square plus 2n minus 400 equals to 0. 6n square plus 2n minus 400 equals to 0. So we got n as minus 25 upon 3 and 8. So our answer will be 8. And yeah, we can neglect this value because number of terms can never be negative, so we neglect this and the answer will be 8. Pretty straightforward. Moving on to the next question. Four numbers are inserted between the numbers 4 and 34 such that an AP results. Okay, we are given 4 here and we can assume 34 here. We have to insert 4 number here such that this whole thing is an AP, right? So for this whole thing to be an AP, how many terms are there? 1, 2, 3, 4, 5, 6. 6 terms. This is the first term, this is the last term. 34 equals to 4 plus n minus 1 into d. And how much is n? N is 6. So we can directly write it as 5d. So we can get d equals to 6. Or you can directly use the formula d equals to b minus a upon n minus 1. Yeah. This is just similar to inserting n number of AMs between a given range A and B. Yeah. So find the smallest of these four numbers. Okay. So we can now find the whole AP using this D. First number will be 4, next number will be 4 plus 6, 10. Next number will be 10 plus 6, 16. Next will be 16 plus 10, 6, 22. Then 28. And then 34. We have to find the smallest of this four. The smallest is 10. Moving on to the next question. Find the sum of all 3-digit natural numbers which on being divided by 7 leaves a remainder equal to 6. Alright, so what do we write when we want to have a number which is divisible by 7? We can write that number as 7k, and k can equal to be any natural number or be it any number, natural number, integer, real number. That number will be divisible by 7 until and unless we have this thing. So to have a number which on divided by 7 leaves a remainder equal to 6, we can write that number as 7k plus 6, and k can have any values, any real number. So let's say we put k equals to 2. So here if we put k equals to 2, what number will we get? 7 into 2, 14. 14 plus 6, 20, right? 20. And when we divide 20 by 7, we will get the remainder as 6, right? So yeah, that's the main concept of it. And let's move forward. And we want to find the sum of all the 3-digit natural numbers. What are the 3-digit natural numbers? 100 to 999. So we can write this as, we want this number to be between this range. So we can write this as 7k plus 6, 9, 9, right? We can subtract everything by 6 and we can get 94 less than 7k less than equal to 993. We can divide everything by 7 and we'll get 13.43 and 141.86. 13.43 and 141.46. So we got the values of k, which will be up to 141 starting from 14, right? So what will be the first term that will be divisible by 7 and give a remainder of 6? We will get that first term at k equals to 14. 7 into 14 plus 6, which will equal to 104. What will be the last term that we will be getting at 141? 7 into 141 plus 6, that will be equal to 993. And how many numbers are there actually between these? There are 141 minus 14 plus 1 numbers, because we have to include both of them also. So there are 128 numbers. Now this is just similar to an AP where the common difference, that will be 7. The first term is 104, the last term is 993, and we have the formula for the n terms of an AP as n by 2 a plus l, right? So we can just plug in the formula now. N equals to 128. 128 upon 2. First term is 104 plus last term is 993. And when we will solve this question, when we will solve this value, the answer will come 70208. 70208. Okay. So yeah, moving on to the next question. Question number 25. The sum of the first three terms of an AP is 24. We are given first three terms: A plus, oh, A plus D, and A plus 2D. We are given 24. The sum of the squares of the first term and the second term is 80. A square plus A plus D whole square is 80. Find the eighth term of the progression if its fifth term is known to be exactly divisible by 10. A5 is of type 10k. That's only when we know that it is divisible by 10, right? And we have to find the eighth term of the progression if its fifth term is known to be exactly divisible by 10. We have to find the eighth term. Yeah, we have to find. I mean, this question is pretty straightforward. We can add all this up and we will get 3a plus 3d equals to 24. We will get a plus d equals to 24 upon 3, that will be 8. We can put a plus d here. We will get a square plus 64 equals to 80. Then a equals to 80 minus 64, that will be equal to 16. So a square equals to 16. So a equals to plus minus 4. We got two values of a, and we can plug these two values of a back into this equation. So when we'll put a equals to 4, then a will be equal to, then d will be equal to 8 minus 4, that is 4. But when we will put a equals to minus 4 in this equation, then d equals to 8 plus 4, that is 12. So can you see we are getting two different APs. One is starting with 4 and incrementing with plus 4, 4, 8, 12, 16, 20, and another AP is starting with minus 4, and that is incrementing with plus 12. Then that means plus 4 plus 12, next term will be 8, 8 plus 12 will be 20, 20 plus 12 will be 32, and 32 plus 12 will be 44. So yeah, how can we see which one will be for our use case? So we are given another condition, a5 is a multiple of 10. Here a5 is this 20 and this is a multiple of 10, but here a5 is 44, this is not a multiple of 10. So using that condition we're gonna choose out of these two that this will be for our use case. So now we can find the eighth term using this. Eighth term will be a plus 7d, a equals to 4, d is also 4, right? Yeah, d is also 4, and 4 plus 28, 32, 32. Moving on to the next question. Anita and Babita set out to meet each other from two places 200 kilometers apart. Okay, let's say Anita is here and Babita is here, and this is 200 kilometers apart. Anita travels 20 kilometers the first day, 19 the second, 18 the third, and so on. Okay, she's traveling in a decreasing AP. 20, 19, 18, and so on. Babita travels 8 km first day, 10 km second, and she is traveling in an increasing AP of 8, 10, 12, and so on. After how many days they will meet? Okay, so we have to find after how many days the distance between these two, that will equal to be 0. So how can we get the distance? Let's say after n number of days they meet. Let's just assume it. So after n number of days, how much distance Anita must have covered? We can find it using the Sn formula. Sn of Anita will be n by 2, 2 into 20 plus n minus 1 into 1. And how much distance Babita would have covered? Sn for Babita will be n upon 2, 2 into 8 plus n minus 1 into 2, because the common difference is 2 and the first term is 8. So after n days Anita has traveled this distance, and after n days Babita has traveled this distance, and we are saying that after n days they meet. So either we can do that, no, we can just say that the distance traveled by Anita plus the distance traveled by Babita, that will be equal to 200 kilometers after n days. Let's denote it as Sna and denote it as Snb. So after n days, Sna plus Snb will be equal to 200. So we can just solve and plug in the values. N by 2, 40, no, 40 minus 1, 39, 39 plus n plus n by 2, 16 minus 2, 14 plus n equals to 200. We can take n by 2 common and shift to the other side of it, equals to 39 plus 14 will give us 53. 53 plus 2n will be equal to 400 upon n. So yeah, this is going to be a quadratic equation. 2n square plus 53n minus 400 equals to 0. 2n square plus 53n minus 400. So we get two values of n. One value is around minus 32.6 and another value is around 6.12. Okay, so we are seeing that after 6, like this n is the number of days, so it cannot be negative, right? And we are getting the answer as 6.12. So how can we decide that will our answer be 6, and how we can decide that will our answer be 7? We can just use the equations back again. We can put the value 6 back into this equation, or mm, yeah, back into this equation. When we'll put 6 in this equation, what will we get? We can take n by 2 common. 39 plus 14 was 53, and this will be 2n. So when we'll put 6 in this, we'll get 3. 53 plus 2 into 6, that will be 12. 53 plus 12 gives us 65, and 65 into 3 gives us 195. So yeah, they are traveling 195 kilometers. The sum of their distance will be 195 after 6 days, but for them to meet, the sum should be equal to or more than 200. So now we can plug in 7. 7 upon 2, 53 plus 14. 53 plus 14 is 67 into 7. So that will be 23 to 34.5. Yeah. So we are not getting exactly 200, but we are getting 23.45. So after how many days will they meet? So after the 6th day has passed, they won't be meeting. They will still have 5 kilometers of journey left. So they will complete their 5 kilometers of journey in the 7th day. So the answer will be 7. Okay, so moving on to the next question. Question number 27. If a man saves rupees 1000 each year and invest at the end of the year at 5% compound interest, how much will the amount be at the end of 15 years? So this is a question of compound interest. We can directly use the formula, but we won't be using the formula here. We'll be solving it using geometric progression, right? Yeah, geometric progression. I don't think so it will be an AP. So we can think of this question as, let's say you have a saving of 1000 rupees, and then instead of using those 1000 rupees, you put it into a magic box which makes the money grow by 5% at every year at the end of the year. So if you put 1000 rupees into the box and you are waiting for 1 year, At the end of the 1 year, if you take out the money, how much money will you be getting? You'll be getting 1050, because it will increase by 5%. So then 1000 plus 1000 into 0.05, and you will do this for 15 years. So for the first year, if I say first year you saved 1000 rupees, and you waited for how many years? When you are at the first year and the total time you are giving it to grow is 15 years, how many years will you be waiting? You'll be waiting for 14 years, right? So after 14 years, how much the money will grow? Into 1.05 to the power 14. How are we getting this 1.05? We are getting this as 1000 plus 1000 into 5% of 1000. We can just write it as 50, or we can just take 1000 common here. So what we'll get? 1 plus 5 upon 100, which will give us 1 plus 0.05, which will give us 1.05. And this is for 1 year. And if we are at the first year, we'll be waiting for next 14 years to take the money out. So we'll be getting 1000 into 1.05 into 14. Now we are at the second year. We again saved 1000 rupees. And how many years we'll be waiting now? We'll be waiting for 13 years. Then the amount will be 1000 into this. Now we are at the third year. We again saved 1000 rupees. So now the amount will be 1,105 into 12, because we are going to wait for 12 years, because we are already at the third year. So from third year we'll be waiting till the 12th year to complete the span of 15 years, and this will continue till the 15th year. At 15 year we saved 1000, but when we are at the 15 years we are going to take all the money out. So how much money we'll be getting? 1.5 into 0, right? So can you see the pattern here? The pattern is just like a GP. We have, so how much will be the total amount? From the first year we got this, second year we got this, third year we got this. Similarly, it gets reduced each by year. So the total amount will be the sum of this. Let's say total amount is A, 1000. You can take 1000 common. 1.05 to the power 14 plus 1.05 to the power 13 up to 1.05 to the power 0. So here what's the common ratio? The ratio is 1 upon 1.05, because how do we find the ratio? We find the ratio by using AR plus 1 upon AR. We take the first term ahead of us and we divide it with the term behind it. So power 13 will be in the numerator and power 14 will be in the denominator. So power 1 will be left in the denominator and numerator will be 1. And what's the first term? 1.05 to the power 14. So if we solve this, we'll get 1 upon 1.05. This term will be less than 1. So we'll use the formula of Sn when r is less than 1, and that formula is a 1 minus r power n upon 1 minus r. Just plug in the values now. And what will be n? How many terms are there? 1, 2, 3 to 15 years. 15 terms are there. These are 15 terms, so n will be 15 minus 1 upon 1.05 raised to the power 15 upon 1 minus 0.05. We can just solve this as 1.05 raised to the power 40 divided by 1 minus 0.05 to the power 50 upon 1 minus 1. Yeah, so after solving this Sn, we'll get to 1.578. What was the amount? Our amount was A into 1000 into 1.578. So we'll get 21578. Option number B. Next question. If sum of n terms of a series is given by 2n plus 7, then its second term will be given by. Okay, so the concept here we'll be using is as such. If we are finding the sum of n terms, what do we get? If the first term is a1 of any series, not just specifically ap or gp, because here we are given just any random series. We are not said that this is a ap or this is a gp. We are just told that this is a series and the sum of first n terms, the sum of n terms of the series is 2n plus 7, and those n terms can be any terms. We take Sn, then Sn is what? An plus a2 plus a3 up till an, right? Sn is this. And what if we want to find a1 out of this? Just see it as a straight line, and if we can somehow subtract this amount from this amount, we can get this amount which is left, and the left one is a1. So we are told to find the second term will be given by. So what does S1 will give us? S1 will directly give us the first term because we are just taking A1. Then S1 is 2 into 1 plus 7, that will be 9. So the first term is 9. What will S2 give us? S2 will give us A1 plus A2. We'll put 2 here. 4 plus 7, 11. So now we have S1, that is A1, and we have S2, that is A1 plus A2. So we can subtract this from this, and what will be left? Only A2. S2 minus S1, 11 minus 9, 2. A1 will get cancelled out, goes to A2, 2. Pretty simple. If A is the sum of n terms of series, 2 plus half plus 1 by 8. B is the sum of two n terms of the series, 2 plus 1 plus half, value of b by a. Okay, 2 plus half plus 1 upon 8 up to n terms. What is this? This is a geometric progression with common ratio 1/4 and first term 2. So sum of n terms will be, mm, we have to make sure that, not make sure, like we can see that r is less than 1, so we will using that particular formula for that. The sum of n terms is a 1 minus r raised to the power n upon 1 minus r. So this is Sn for this, and what are we given? We are given that this is equal to a. Now see the other thing. The other series is 2 plus 1 plus 1 by 2 and so on. This is indeed another GP with a equals to 2, but here r equals to 1 by 2, not 1 by 4. 1 upon 2 is just 1 by 2. But here also r is less than 1, so we'll use Sn equals to a 1 minus r raised to the power, but here we were given 2n terms, so we'll write 2n upon 1 minus 1 upon 2, and we are given that this is equal to b. The main problem here is not making these equations. The main problem here is how to solve for b by a. We have to divide this. Now first we can write it in a little simpler way. We can write 1 minus 1 upon 4 as 3 by 4, and we can take 3 here and 4 up here. Similarly for this one, we can write 1 here and we can take 2 here. Now we can divide b by a and we'll get, okay, we can do one more thing, because here the power is 2n and here the power is n, and here it is 1 by 4, so we can write 1 by 4 as 1 by 2 whole square, and if 1 by 4 is already raised to the power n, we'll get 1 by 2 raised to the power 2n. So we can write 1 by 4 raised to the power n as 1 by 2 raised to the power 2n, right? So we got similar kind of things here. Now we can directly divide this equation, equation 1 by equation 2. The numerator will almost get cancelled. Okay, I'll just write it. 2 into 2, 1 minus 1 2 raised to the power 2n upon 1 into, the equation 2 will get reciprocal and then we'll write it. This thing get cancelled completely. 1 2 gets cancelled, and then we get b upon a equals to 3 upon 2. Next question. A man receives a pension starting with rupees 1000 for the first year. Each year he receives 80% of what he received the previous year. Find the maximum total amount he can receive even if he lives forever. Okay. Oh, it's Aman, not a man. Aman receives the pension starting with 1000. 1000 is the pension for the first year, and each year he receives 80% of what he received the previous year. That is, his pension is getting reduced by 20%. So first year the pension was 1000. Next year his pension will be 80% of this 800. Next year again his pension will be less, 80% of this, that will just be equal to 800 into 0.8, 640 rupees. But we should not write like this, rather than first year the pension is 1000, next year the pension is 1000 into 80 by 100. Next year the pension is 1000 into 80 by 100 into 80 by 100. So yeah, this is gonna repeat up till infinite terms, because we are told find the maximum total amount that he can receive even if he lives forever. So what will be the GP out of this? We can take 1000 common and we'll get 1 plus 0.8 plus 0.8 square up till infinity. What is the common ratio? 0.8. The first term is 1. Sum of infinity is a upon 1 minus r, 1 upon 1 minus 0.8, 1 upon 0.2, which is nothing but 5. So what will our sum be? 1000 into 5, 5000, 5000. Great. The pattern here is like, this is a telescoping series though. What are telescoping series? Let's consider an example of 1 minus 1 by 2 plus 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 plus 1 by 4 minus 1 by 5. And how we will find the sum of this thing? This looks scary, but if you look closely, this is 1 minus 1 by 2 here. The sign of 1 by 2 is minus here, and the sign of 1 by 2 is plus here. Similarly, the sign of 1 by 3 is minus here, the sign of 1 by 3 is plus here. So if you open the brackets and add, this thing will get cancelled, this thing will get cancelled, this thing will get cancelled. And what are we left with? We are just left with 1 minus 1 upon 5, the first term and the last term, difference of that. So our answer simply is 4 by 5. We don't have to solve the whole thing, the answer is so simple. So this type of series are called telescoping series. The general form of this series, these telescoping series, they look like 1 upon n plus 1, 1 upon n plus 1. That is, one something is in the numerator, most probably 1, and in the denominator it is like a number multiplied by a number which is 1 more than that. 1 into 2, or 1 into 3. Why such general term? Because we can break this term into something special. How can we break that? We can break this thing into 1 upon, no, yeah, wait. We can break this as n minus 1, n plus 1 minus n. We can write the 1 in the numerator as such because n will cancel. At last we are left with 1 only, and the denominator will be as such. Now we can open this fraction and we'll take this as one thing and this as another thing. So we'll get 1 upon n minus 1 upon n plus 1. So yeah, that's what we are getting. And here also it is similar kind of thing. It is 1 in the numerator, some number in the denominator n, and some number more than that. Although here that number is not just plus 1, here that number is plus 4. So we have to think of some middle number to solve this. Let me just clear this out. The first term is 1 upon 1 into 5. Now, how can we write this thing into that telescopic form? Hmm? It is 1 and this is 5. What comes between 1 and 5? 2, 3 and 4, right? So if we write it as 1 upon 4n minus 3 into 4n plus 1, and what will be n? N will start from 1, 2 up till here. We don't know what this term is, but it will go till here. First let's check that is this correct or not, because when we put 1 here we'll get 4 into 1 minus 3 1, and 4 into 1 plus 1 is 5. So we will get this term. So this is correct for this. What is the next term? For n equals to 2, 5 into 9. We should get 5 into 9. 1 upon 4 into 2, 8 minus 3, 5. 4 into 2, 8 plus 1, 9. Yeah, we are getting 1 upon 5 into 9. So this is indeed the general term for this series. And we are given this here 221. So 4n minus 3 should be equal to 221. So from here we should not use this 221. We should use this 4n plus 1 equals to 225. And why are we using the latter term? Because when I told you the example of 1 upon 1 minus 2, 1 upon 1 upon 2 minus 1 by 3, and it went up to 1 upon 4 minus 1 upon 5. So if you saw when we added all of these terms, everything got cancelled. Even the 1 upon 4 got cancelled, and the last term left was 1 upon 5. So here also everything will get cancelled. Even this 1 upon 221 will get cancelled, and the last term will be 1 upon 225 kind of something. So that's why to get the total number of terms in this series we are taking the latter term and not the previous one. So from here we can find the value of n. N will be equals to 224 upon 4. 224 divided by 4 is 56. So we got 56. And the Tn for this was 1 upon 4n minus 3, 4n plus 1. Now we can just use partial fraction method. Partial fraction is a kind of a method to separate these fractions. We can write this as something which we don't know, which we have to find upon this, plus something. Okay, I'm writing it wrong. Something with this 4n minus 3 and something with 4n plus 1. We can break this thing into this thing. A and B can be anything. It's just like we are breaking 1 upon 2 into 5 into something which comes with 2 plus something which comes with 5. We just don't want to guess it because we cannot guess everything here. It's a little bit complicated. It's not that complicated though. You can see 4 and 4 and that will get cancelled easily. But anyways, this is a general method. You can use this method without using your brain. So we can just cross multiply here, right? 1 upon, we are solving this whole thing now. 1 upon 4n minus 3, 4n plus 1. Here also we will get same thing in the denominator. But here with a we'll be getting 4n plus 1. And with b we'll be getting 4n minus 3. The numerator will get cancelled. And now 1 equals to this thing. Now we can just put in values. And we don't want to put any arbitrary value to find this because that's gonna be more complicated. Now can you tell me, if we want to find a and b, what's the easiest method? The easiest method that one can think of is, how about we make this a term equal to 0? If this is equal to 0, then b will directly equal to 1 and we can find the value of b. So how will that equal to 0? When we'll make this 4n plus 1 equals to 0, and when will this 4n plus equals to plus 1 equals to 0? When n equals to minus 1 upon 4. So we'll put n equals to minus 1 upon 4 in this whole equation and we'll get, now this thing will be 0 plus b into 4 into minus 1 upon 4 minus 3. So what do we get? 1 equals to b into minus 1 minus 3 minus 4. So b equals to minus 1 upon 4. Similarly, now how we will get a, making this b equals to 0? When this b will equal to 0? When 4n minus 3 equals to 0, n equals to 3 upon 4. So 1 equals to a into 4 into 3 upon 4 plus 1, a equals to 1 upon 4. Right? So what do we get? A equals to 1 upon 4 and b equals to minus 1 upon 4. So how can we write this now? We can write that fraction, the values. We can put value of a here, we can put the value of b here. 1 upon 4 upon 4n minus 3 plus minus 1 upon 4 upon 4n plus 1. Right? This is our Tn now. If you'll take the LCM and solve everything again, you'll again get back 1 here and this same denominator here. We just broke it. We just broke this fraction line into 2 and just put 1 here. We can take 1 upon 4 common and we can write it as 1 upon 4n minus 3 minus 1 upon 4n plus 1. So now can you see we got something similar? We got something like this term minus this term, and we can now just put value of n equals to 1, n equals to 2, n equals to 3 up till there. So I'm gonna erase this thing. I'm directly going to write the partial fraction now. What was the Tn we got? We got it as this, right? So now we can again put the value of n equals to 1 here. At n equals to 1, we'll get T1 1 upon 4, 1 upon 4 minus 3, 1 minus 1 upon 4 plus 1, 5. What will be T2? 1 upon 4, 1 upon 4 into 2, 8 minus 3, 1 upon 5 minus 1 upon 4 into 2, 8 plus 1, 9. Can you see it now? 1 upon 4, 1 upon 9 minus 1 upon 13, right? Can you see it now? If you will add, what will be the sum of n terms? It will be just T1 plus T2 plus T3 up till T54, because we found T equals to 54, n equals to 54 using this, right? N was 54, 54 or 56? No, it was 56. Yeah, it was 56. Because 4n plus 1 equals to 225, n equals to 56. 56 up to 56 terms, up to T56 we have to add all of this. So what will be the T56 here? 1 upon 4. Just put the 56 value in this formula. We don't care about the first term because it will get cancelled eventually. We just care about the latter one. 56, 4 into 56, 4 into 56, 224 plus 1, 225. And if we add this now, you can see this 1 by 5 will get cancelled with this 1 by 4, this 1 by 9, 1 by 13 with some 1 here, this will get cancelled by this, and we'll be left with just this. So the sum of 56 will be 1 upon 4, 1 minus 1 upon 225, 1 upon 4 into 224 upon 25, 56 upon 225. This is a pretty long question, but once you get the pattern, you don't have to go through all of that again and again. You could just directly write it as 1 upon 1 minus 5 plus 1 upon 5 minus 1 upon 9, and after you know the pattern, you will directly be knowing that the final answer will be just 1 minus 225, and something will come here. You have to figure that out. But yeah, it's gonna be easy after you practice it for a while. First time is always going to be difficult. So the next question is again indeed another telescoping series, but we cannot directly see the telescoping pattern here because we cannot see any negative sign and we are not able to find that no terms are getting cancelled. But we are given this kind of bullshit here, some irrational numbers in the denominator, so we should rationalize them. We're just trying to rationalize the first term. So we got root 4 minus root 3, and if we do to the second term we'll get root 5 minus root 4. If we do it to the next term, that will be root 6 minus root 5. So can you see the pattern here? This minus 3 is not going to be cancelled. This root 4 minus root 4, root 5 minus root 5, root 6, and the next term will be root 7 minus root 6, root 6, root 6, and it will go up till here. So what will be the last term? Root 225 minus root 224. The bigger number is before the negative sign and the smaller number is after the negative sign. That's the pattern here. 5 is greater than 4, 5 is before 4, 6 is greater than 5, 6 is before 4. That's why 225 is greater than 224, 225 is ahead of 224. And what are the numbers getting cancelled? 4 is getting cancelled, 5 is getting cancelled, 6 is getting cancelled, 7 is also get cancelled. So this 224 will also get cancelled. So what will be left? This root 3 and root 225. Root 25 is nothing but 15. So our answer is root 25 minus root 3, 15 minus 3. Find the sum of series 1 plus 1 upon 3 plus 1 upon 6 plus 1 upon 10 plus 1 upon 15. Here we cannot see any GP. This isn't a GP though. 1 upon 10 minus 1 upon 6 minus 1 upon 15. We have to make it a GP because we are told to find the infinite sum. So we have to make it how can we do that? We can just 136 136 136 10 50 up till infinity. How can we write these terms? N plus 1. This is the first term. N plus 1 upon 2. If we put n equals to 1 here, we get 1. If we put n equals to 2, we get 3. If we get n equals to 3, we get 6. This is just like each term is the sum of the natural numbers up to that term. If this is the fifth term, then fifth term equals to the sum of first 5 natural numbers. Fourth term equals to sum of first 4 natural numbers. Sixth term equals to sum of no. Third term equals to sum of first 3 natural numbers. So what do we get? We got the pattern for denominators. So we can write Tn equals to 1 upon Nn plus 1 by 2, 2 upon Nn plus 1. So S infinity will be equal to sigma n1 till infinity Tn, or that will be equal to sigma n1 to infinity 2 upon Nn plus 1. We can again use partial fractions, or we can just take 2 out of here. 2 inside the bracket, we'll get n equals to 1 sigma 1 upon n Nn plus 1. And this is just like the example I told you before in this question, when I was telling about the telescopic series for the first time. How can you separate this? 1 upon Nn plus 1. How can you separate this? You can just write n plus 1 minus n upon Nn plus 1, and you can separate it as 1 upon n minus 1 upon n plus 1. Mm, 1 upon n plus 1 minus 1. We can take this, so that will be 1 upon n minus, then we can take this, so we can write 2 sigma n equals to 1 till infinity 1 upon n minus 1 upon n plus 1. Right. So again we got this telescopic pattern where the first term is 1 upon 1 minus 1 upon 2, then second term is 1 upon 2 minus 1 upon 3, then fourth term is 1 upon 3 minus 1 upon 4, fifth term is 1 upon 4 minus 1 upon 5, and it keeps on going like that. It keeps on going like that to infinity. Now, how do we find the answer till infinity? We have to take the limit. Many of you won't be familiar with the concept of limit, but we we can think of it like If we put the last term here, if we put infinity here, 1 upon infinity, what will we get? 0. And again 1 upon 1 plus infinity will again get 0, because 1 upon a very big number, 1 upon a very big number, let's say a number 10 is to the power 10. If you solve this, you get a very small number, 1 upon 10 is to 10 is to the power minus 10. This is a very small number, so you can just ignore it. So similarly, we are getting, when we'll go till infinity, we'll be getting very small numbers here, because n will be so big, we'll be getting very small numbers. So you can just directly ignore this thing out with 1, and you can just get 2. Not a very good way to solve at last. We have to use the concept of limit here. We have to take limit into infinity, something like that. And when we'll solve this, you will be eventually getting just this 2 out of the sum of the sum of, oh, there are the other options. Let me just get the other options first. 34. And let's ignore these. The sum of the series up to n terms will be. Now, this question is very lengthy, pretty lengthy. We'll solve this question using the options, because we are given in the options itself, we are given the sum in the form of n. So what does Sn means? It means the sum of n terms of that series, be it any series. What does S1 means? S1 means we'll just get A1. S2 means we'll get A1 plus A2. And using this series, we can find what is A1. A1 is 15, A2 is 35. So S1 should equal to 15, A1 plus A2, S2 should equal to 15 plus 35, that is 54, yeah, 50. So using these two, and if required further, because we can easily find S1, S2, S3 till S4, maybe we can easily find that. We'll just look which option on putting n equals to 1 gives us 15. If we see the first option, option A, if we put n equals to 1, we'll get 1 here, 1 in the numerator, 1, 4 plus 18 plus 23, 4 plus 18 plus 23 gives us 45. 45 divided by 3 gives us 15. So indeed the first option is giving us 15. Now see the second option. In the second option, 1 here, 4 plus 18 plus 23, it will give us 45, because it's the same as that. But 45 is not divided by 6. It won't give us 15. It will give us 15 upon 2. And here also, and here we'll get 45. Option C will give us 45. So for more clarification, because during the pressure of exam, if a student sees the option is getting matched on the first term, no one can stop the student from marking it as the correct answer, because that's another kind of excitement to get the option correct in the first try. So just to be clear, we are gonna solve for S2 also, because one of the option is none of these. What if this thing is not satisfying for S2, for S3? What if it is just satisfying for S1? So the answer will be none of these. So we'll check for S2 also. 35. Hmm. So we'll put 2 here. What will we get? 2, 4 into 2 square plus 18 into 2 plus 23 upon 3. So that will be 16 plus 36 plus 23, 75. 2 into 75 upon 3, 25, and we get 50. And S2 is also 50 that we found. So yeah, option A should be correct. 34. We did it using the options because this question is pretty hectic, pretty lengthy, and solving completely in exam, it is not possible, not at all. So the next question is the sum of the series this up to 6 terms. This we can again make it into the telescopic series, and again everything will get cancelled and only the first and the last term will be there. Mm, we'll try finding a pattern here. The sum of first term is 1 upon 3. Sum of second term is 3 upon 5. Sum of third term, sum of first 3 terms, 1 upon 3 plus 4 upon 15 plus 4 upon 35, 5 upon 7. So the pattern is as follows. Sum of 4 terms will be 7 upon 9. Sum of 5 terms will be 9 upon 11. Sum of 6 terms will be 11 upon 13. None of the option matches. None of these. For the above question 35, what is the sum of the series if taken to infinity? Hmm. Like, hmm, what was the pattern of sum? The pattern of sum was some number upon some number, that number plus something more. The answer will be none of these, I guess. 36. Answer to 36. The what was the pattern here? The pattern of Sn was, these are indeed odd numbers. How can we write odd numbers? 2n plus 1 upon, and it was the next odd number, 2n plus 3. So if we put infinity here, 2 into infinity plus 1 upon 2 into infinity plus 3. Or we can write it, we can assume this number as a, and we can write this as a upon a plus 2. We can break this into partial fractions. A upon a plus 2, we can break it as a upon a plus b upon 2. So we get and we'll just take this a outside. So 1 equals to 2a plus ab. How can we make this 0? A cannot be 0, it should be 2. It's gonna be like uh, 1 minus 1 upon a plus 1 a plus 2 a plus 2 minus 1 upon a plus 2. We are getting 1 extra. We can add 2 here. Yeah, we'll get this as if we want to break this, this will be 1 upon this, because if you solve this a plus 2 minus 2 upon a plus 2, you get that thing again, and this thing is multiplied by a. So if we put a to infinity here, something upon infinity will give us 0. Only 1 is being left. And what is this option? I don't know. It's gonna be b or a 36. The answer to 36 is option B. Okay, this is 1.1. So we are not getting 1.1, we are getting 1. So B. Next question. Answer these questions based on the following information. There are 250 integers a1 to a20, 250, not all of them necessarily different. Let the greatest integer of these 250 integers be referred to as max and the smallest as min. The integers a1 through a124 form a sequence A and rest form a sequence B. Each member of A is less than or equal to each member of B. Okay, we have this a1 to a250 and max number is capital M, minimum number is small m. It can be any of these. And now we have broken this into two sequence. What is A? A is A1 to A2 to A124. And what is B? B starts from 125, 126 up to 250. and each member of A is less than, that is, each member of A is less than or equal to each member of B, or we can write it as Tn of A is less than Tn of B. All values in A are changed in sign while those in B remains unchanged. Which of the following statements is true? Every number of A is greater than or equal to every member of B. Max is in A if all the numbers originally in A and B had the same sign, then after the change of sign the largest number of A and B is in A. None of these. So we can think of it like all members of A are smaller than all members of B. Hmm. We have to see how the sign changes. Let's assume a sequence. Let's just assume that the sequence A is 1, 2, 3, 4 up till 124 and sequence B is up till 250. So according to this thing, this is one sequence, this is another sequence. Every member of, so all the values in A are changed in sign. So this is now -1, -2, -3, -4, -124. Every member of A is greater than or equal to every member of B, which is not true. -1 is not greater than any of this. The first option is now max is in A. Before max was in B, and here also max cannot be in A because all the numbers are negative now. Max cannot be in A. If all the members originally in AB had the same sign, okay, they had the same sign. After the change of sign, the largest member of A and B is in A. No, it is not in A. No. So none of this is correct. Elements, this is the same following. Elements of A are in ascending order and those of B are in descending order. A124 and A125 are interchanged, then which of the following statement is true? If elements of A are in ascending order, then the last term A124, this should be the largest term if elements of A are in ascending order. Also 125 would be the largest value of B because it is in descending order. Let's say A was 1, 2, 3, 4, only this. So A124 is this. So this is the largest number in all of these. And let's say B is 9, 8, 7, 6. This is 125, A125. Largest number in all of this is this also. So, and we are interchanging this A124 with A125. Okay. A continues to be in ascending order. If we interchange this, now it will become 1, 2, 3, 9, 4, 8, 7, 6. A continues to be in ascending order. Yeah, A is still in ascending order because 9 was the largest number and 9 is biggest. out of all of these. B continues to be in descending order. No, B is not in descending order now. 4 is smaller than 8. A continues to be in ascending order and B in descending order. No, B is not in descending. Option A. Every element of A is made greater than or equal to every element of B. Every element of A is made greater than or equal to every element of B by adding each element of A an integer x. Okay. So what was our till 124? This was our assumption of A and this was our assumption of B. Every element is made greater than now. Hmm. Greater than or equal to every element of B by adding each element of A by an integer x. Here the minimum value is 1 and the maximum value is 250. If we have to make this 1 greater than 250, what would be the value of x? X should be greater than 250. If this is the minimum value and we'll take the value after it, 2 and 249. What should be the number x multiplied by 2 so that this is greater than this now? 249 upon 2. So what are we doing? We are just subtracting it, the maximum minus minimum. I mean, this is just a question of visualizing things. 2 to the power 10, very blank, nothing, no hint of that cannot be true. Smallest value of B. Smallest value of B is 125. If we multiply 1 with 125, it's still less than 250. So, not gonna be true. Largest value of B. Largest value of B is 250. If we multiply 250 by 1, yes, it is going to be greater than or equal to 250. Cannot be less than. But a better option would be maximum minus minimum. 39. Yeah, D is correct. So for the 40th question, we'll have a approach where we'll use the options to find. After reading the question, like it's a pretty complicated question. If you want to solve it exactly and want to get the exact value, it's pretty complicated. We're not going into that. So this is the information given to us. We are given that in the fifth row, the sixth number is 37, and in the same fifth row, the 20th number is 73, and in the 25th row, the sixth number is 63, and the 20th number is 87. So And we are also given that each row is a separate AP and each column is also a separate AP. Like this is an AP, this is an AP, this is an AP, going like this. And this is an AP, this is an AP, and this is an AP, going like this. So we'll so if this is an AP, we can find the value of A and D using the equations like A plus this is the sixth number 5D equals to 37, and A plus this is the 20th number 19D equals to 73. If you will solve these two equations, you will get the value of A and D as such. You can solve yourself, right? So from here we get the value of A and D, and now we can use the formula of Sn where n equals to 25 because these are 25 numbers in the fifth row. You can use the formula to find the sum of this row only the fifth row. So the sum of fifth row will come 1375. And how many numbers are there in the fifth row? 25 numbers. So what will be the average number in each block? Total sum divided by number of terms. Total sum is 1375 and there are 25 terms, so divide by 25 we get 55. Similarly, we'll find the average of this. First we'll find A and D again. Similarly, we get A as this, D as this, and sum of 25th row is 1875, and when we divide it by 25 we get 75. Similarly, now we'll do this. We'll do column wise because these are also an AP. We'll find again here we found the A, but here this is the fifth term, so we'll write A plus 4D, and this is the 25th term, A plus 24D equals to 63, D equals to 13 by 10, A equals to 15 by 9, and the sum of the sixth column is 1185, which on average it comes to be 47.5. So now we have the average of fifth row, 25th row, and the sixth column. We have the average of these three individually. It means कि the average number in each cell of fifth row is 55. The average number in each cell of the 25th row is 75. The average number in each cell of sixth column is 47.5. So like it's like we are having this, this, and this. So if we just add and find the final average of this 55 plus 75 plus 47.5, let me see what will we get. 55 plus 75 plus 47.5, we'll get 177.5 divided by 3, and we get a number around 60. So after getting the average of how many numbers were there, 25 numbers were there, 25 numbers were here, 25 numbers were here. After getting the average of 75 numbers, we are getting that in each column there is about the value of each number in each cell is about 60. It's around 60ish. So now we have the sum of all the 625 numbers. According to this option 65596, if we divide it by 625, what is the average number we are getting? 65596 divided by 625. We are getting the average number as 104. But according to our calculation, the average should be around 60. But it is coming around 104, so this cannot be the sum. If we try this, 52900 divided by 625, we get the average around 84. This is pretty close but still pretty far. Try this. 32798 divided by 625. No, 6. Yeah, 6. So here we are getting it around 53, which is pretty close to 60. So according to this, our answer should be A. But yeah, it can be none of these also. So to exactly solve this, you have to go in the bigger method. That's gonna be pretty hectic. How many 4-digit numbers have the property that the digit taken from left to right form an AP or a GP? Hmm. Here's the question. How many numbers, 4-digit numbers, uh, what are the four total 4-digit numbers? 100029999 have the property that the digit taken from left to right makes an AP or a GP. We have to see both. So we'll check all the numbers. Hmm. If the digits are in AP, then if the digits are in AP, then they should be like A plus D, A plus 2D, A plus 3D, and A cannot be equal to 0, because if A equals to 0, then what will the number be? 0 or some number here, some number here, some number here. But we want a 4-digit number, so this is not a 4-digit number. This became a 3-digit number, so A cannot be 0. So we got one condition, that A is not equal to 0. So mm, we can see it like hmm, each digit must be from 0 to 9, because only 0 to 9 are the possibilities. So the value of A cannot be 0. So value of A can go from 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Value of A can go from this, and all the four terms are digits. Hmm. 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 So if we put A as 1, we can get different values of D, such as 1, 2, 3, 4, 5, 6, 7, 8, 9. But the maximum value for this cannot exceed 9, because it has to be a digit between 0 to 9. So it can be like 1, 2, 3, 1, 3, 5, 7, 1, 4, 7. This won't work, because after 7 it will be 10. So, and now if A is 2, we can take the difference here, the common differences. and common difference is 2, 2, 3, 4, 5, 2, 4, 6, 8, 2. Here the common difference is 3, 2, 5, 8, 11. No, this won't work. 3, 4, 5, 6, 3, 5, 7, 9, 4, 5, 6, 7, 4, 6, 8. Again, this won't work. 6, 7, 9, 5, 7, 9. Again, this won't work. So after that, only D1 will satisfy. 5, 6, 7, 9, 6, 7, 8, 9, 7, 8, 9. And after that, this won't work either. So how many numbers we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got 9 numbers here. We can get more numbers like that. What are the numbers we missed? Hmm? Oh, we missed the numbers where the last one can be 0 also. Then, oh, okay, we can reverse them also. 1, 2, 3, 4, 4, 3, 2, 1. 4, 3, 2, 1 will also be a number. 1, 3, 5, 7, 7, 5, 3, 1. 2, 3, 4, 5, 5, 4, 3, 2. 2, 4, 6, 8. Oh, I did not try it. 5, 4, 3, 2. 2, 6, 2, 4, 6, 8. 8, 6, 4, 2. 3, 4, 5, 6. 6, 5, 3, 4. 3, 5, 7, 9. 9, 7, 5, 3. 4, 5, 6, 7. 7, 6, 5. 9, 7, 6, 5. 9, 8, 7, 6. 9 numbers. Again 9 numbers. Here these are 9 numbers. Okay, but we are assuming that a is not equal to 0 because we have said that a is the first digit, so a won't be 0, but a can be the last digit. So if we see as a equals to 0 and d equals to 1, then we'll get 0, 1, 2, 3, then d equals to 2, 0, 2, 4, 6, then d equals to 3, 0, 3, 6, 9, then d equals to 4, 0, 4, 8, 12. So this won't be true. And now these are not 4 digits number, these are 3 digit number, but when we reverse them, 3, 2, 1, 0, 6, 4, 2, 0, 9630. These are indeed 4 digits numbers. Oh, so these are only 3. So this is 9, this is 9, and this is 3. So we get 21 numbers as such. And for the GP, we can again assume A to be 1, then 1, 2, 4, 8, and after this 1, 3, 9, 12 would be the case. Here D equals to, oh, not D, R equals to 2, and A equals to 1, then A equals to 2, 2, 4, 8, 12 won't be the case. So after 1 it won't work, but this, if we reverse this, 8, 4, 2, 1, this is also a number. So 2 numbers with GP like that. So total numbers 23. Hmm. So the question number 44 says an arithmetic progression P consists of terms from the progression. Okay, so we are not given how many terms it consists of, we are just told it consists of some terms. From this P we make 3 different progressions. From this P we make P1, P2 and P3, such that P1 is obtained by the first, fourth, 7th, 10th term. P2 is second, 5th, 8th, 11th term, and P3 is third, 6th, 9th, 12th terms. Okay, it is found that out of P1, P2 and P1, this is probably a typo here in the question. Maybe it should be founded out of P1, P2 and P3 to have the property that their average is itself the term of the original progression. Okay, so we are told that out of these three, from these three, any two, the average of any two is equal to the third progression, and that third progression is a part of the original progression P. Okay, so first let's check P1 and P2. Let's first make the, let's consider this as A plus D, A plus 2D. This is our P. So P1 will be A, then we want the fourth term A plus 3D, then the seventh term A plus 6D. P2 will be, it starts from the second term, that is A plus D. Second term will be A plus D. Then fifth term will be A plus 4D. Then eighth term will be a plus 7d, and here third term will be a plus 2d, a plus 5d, a plus 8d. Okay, so let's check p1 plus p2. p1 plus p2 will be the first term, 2a plus d, 2a plus 7d, 2a plus 15d. What is the common difference? Oh, we want the average though. So we have to divide it by 2 also. So this will be a plus d by 2, a plus 7 by 2d, and so on. So this is not the part of the original series, because original series is something like this, and we are getting d by 2. We are getting fractions. Let's try p1 and p3. A, so we'll do this. A 2a plus 2d, and then a plus 3d plus a plus 5d, which will be 2a plus 8d, then a plus 6d plus a plus 8d, 2a plus 14d, and divide by 2 because we want the average. Everything will be divided by 2. A plus d, a plus 4d, a plus 7d, and we can see that this is the terms in this only, because after a point we have written only till a plus 2d, we'll be getting a plus 4d, we'll be getting a plus 7d. So yes, the average of p1 and p3, and also see this, p1 and p3 is also equals to p2. The average of each term of p1 and p2 gives each term of p2, and as p2 is a part of p, so this is true. Okay, so now we have to find the possible value of n. So we have to find how many, till how many p should be there. Let's check the options. Let's say 20. So in p1 there will be first term, second term, third term, fourth term, fifth term, till 20th term. So p1 will be first term, fourth term. If this is p1 will be first term, fourth term, seventh term, 10th term, 13th, 16, and 19. p2 will be second term, fifth term, eighth term, 11th term, second term, fifth term, eighth term, 11th term, 14, 17, 20. p3 is third, sixth, ninth, third term, sixth term, ninth term, 12th term, 15th term, 18th term. Okay, so if we will mm, Which of the following can be possible values of n? It can be any, it can be all of these because it is satisfying the condition. So the answer should be all of these, but the only option, the best option is A and B. So yeah, we will choose this. For the above question, if the common difference between terms of P1 is 6, what is the common difference of P? Common difference of P1. Common difference of P1 is what? 3D. 3D equals to 6. D equals to 2. 45. 45 2. Okay. So next question is 46 to 48. If S equals to A, B, B, C, 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 D, 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 till Z, 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 Z. Okay, find the number of terms in the above series. Number of terms are, first A is 1 times, then B is 2 times, then C is 3 times, D is 4 times, then E will be 5 times, F will be 6 times, up till Z will be 26 times. This is just the sum of natural numbers. Sum of natural number is n, n plus 1 by 2, 26 into 27 upon 2, 13 into 27, 13 into 27 gives us 351. Number of terms in this series is 351. Find the find 144th term of the series. Okay, S consists of 1A, 2B's, 3C's and so on. So at what term this will give us 144? Hmm. Hmm. We can just add it like that. 6, 7, let's say after the 10 alphabets like A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. After let's say M is 13th. After M, how many alphabets, how many terms will be there? 13 into 14 upon 2, 13 into 7, 91. Yeah, after 91, 14 n's will be there. So 91 plus 14, and then 15 O will be there. 16 P will be there. So this will be 14 plus 15 plus 16, 136. Till here, till P, after 16 P's, we will be having 136 terms in the series already. We want 144th term. So there will be 17 Qs. So 136 plus 17 will be 153, and yeah, it's so okay. So that will be Q, because after Q the total terms will be 153. So 144, it's gonna be in between. So 144 is Q. If A equals to 1, B equals to 3, C equals to 5, D equals to 7, and Z equals to 51, then find the sum of all the terms. Okay, if A equals to 1, B equals to 3, C equals to 5, D equals to 7, and Z equals to 51, find sum of all the terms. Sum will be the, according to this. So how can we write this? Sum will be 1A, 2B's, 3C, 4D, 5E till 26Z. 26Z. And we are given the value of A as 1, B as 3. So that will be 1 into 1 plus 2 into 3 plus 3 into 5 plus 4 into 7 plus 5 into 9 plus 26 into 50. 1, 6, 15, 28. This is not AP. The difference is 5. 15 minus 6 is 9, and 28 is 13. Here it is the AP. So we are getting the AP after the difference. We can write its general term. The general term will be like, this is the numbers, natural numbers, and then we are having the odd numbers accordingly. So that is n into 2n minus 1. TM for this. So that will be 2n square minus n sigma. To find the sigma, 2 times sigma n square minus sigma of n square. There is a formula for that. Sigma of n square is n plus 1, n plus 1 to n plus 1 upon 6. So 2 n plus 1 to n plus 1 upon 6, and sigma of n is n plus 1 upon 2. Now we can just put the value of n equals 26 into 27 into 53 upon 3 minus, after we solve this we'll get 12051 as the answer. So the next question, if f of 4 of x equals to this, then for how many positive real values of x, f of 2x will be gm of f of x and f of 4 of x. F of 2 of x whole square should be equal to f of x into f of 4 of x. If f of 4 of x equals to 8x plus 1, if f of 4 of x equals to 8x plus 1, it means f of 4 of x equals to 2 into 4 of x plus 1. So now if I put f of x equals to capital X, 2 into capital X plus 1, so this is f of x, then f of 2x will be 4x plus 1. Now just put these equations there. 4x plus 1 whole square equals 2x plus 1 to 8x plus 1. So we can solve this. 16x square plus 1 plus 8x equals to 16x square plus 10x plus 1. X is equals to 0. So x is equals to 5 because x will get cancelled. There are no values of x for which this will be true. No value. If x, y, z are positive real numbers such that x, y, z, w form an increasing AP and x, y, z, okay, these are positive real numbers, x, y, w form an increasing GP, then that is y square equals to x into w, and x, y, z and w form an AP, so y minus x equals to W minus Z. We want W upon X. Okay. We have y equals to 2y equals to x plus z and 2z equals to y plus w. From the property of arithmetic mean and from the property of geometric mean we have this. We want a relation between x and w and x. Okay, we can bring that there. 2y minus z equals to x and 2z minus y equals to w. So w upon x, we can divide this 2z minus y upon 2y minus z equals to w upon x. And we also know hmm, three. Okay, we can use the property of compendo and dividendo here. Compendo and dividendo is like if we have two fractions, let's say a upon b, it is a theory compendo and dividendo. If we have two fractions a upon b, we can write them as a plus b upon a minus b, and they will remain same, they won't change. So I'm just using this property here. Here my a is this and my b is this completely. So a plus b upon a minus b equals to w by x. So if you solve this, you will get 4 z minus y upon z minus y equals to w upon z. So 4 if x, y, z are the mth, nth and bth term respectively of a GP, then we have to find the value of this thing. Okay, mth term of a GP, x equals to a r m minus 1 y equals to a r n minus 1 z equals to a r p minus 1. We have to find n minus p log x. So we can see that they are taking log of x, log of y, log of z. So we are also gonna take log in each of these. Log x equals to m minus 1 log of a r m minus 1, and the property of log a into p. We can write it as log a plus log b, product rule. So log x equals to log a plus log r power m minus 1, and this is in the power, so it can come outside. So log x equals to log a plus m minus 1 log r. Similarly, log y will be log a plus n minus 1 log r, and log z equals to log a plus p minus 1 log r. So now we have the values of this, this and this. We can put the value of log z here, but that will be lengthy. We should think of another shorter solution. N minus p. Or we can just assume a GP, maybe let's say GP is 2, 4, 8, 16, 32. Let this be x, y, and z. So m equals to 1, n equals to 2, p equals to 3. We can put the value n minus p, 2 minus 3 minus 1 into log 2 plus p minus m, 3 minus 1, 2 into log 4 plus m minus n, 1 minus 2 minus 1 into log 8. We can do it like minus log 2. We can break it in power of 2, 2 to the power 2. So this will be 4 log 2, and this is minus 3 log 2. So we can see it's 0. 1 minus 4 minus 3. This is 0. Oh, this was 2. Sorry. So the answer will be 0. We can also solve using this method, but it's gonna be longer. Find the sum of first n groups of 1 plus 1 upon 2. It's similar to that question. Here it is the sum of first n natural numbers, sum of first two natural numbers, sum of first three natural numbers. So here Tn will be n plus 1 by 2, right? So we have to just find the sigma for Tn, that is sigma for n square by 2 plus n by 2. Sigma for n square, I told you that it was n plus 1, 2n plus 1 by 6. So sigma of n square by 2 will be n plus 1, 2n plus 1 upon 6, and 1, 2, there's 12. And sigma of n is n plus 1 upon 2, and 1, 2 is already there, so 4. So take the LCM and solve it. And you can do it like this, or we can just find the value. Putting n equals s equals to 1, s1 equals to 1, s2 should be equals to 4. So here if we put 1, 2, 3, 2 into 3, 6, 1, we get 1. We don't get 1 here. 2, 3, 4, 2 into 3 into 4, 6 into 4. We don't get 1 here. We get 1 only here, 52. Just using the options. We also found it using this. You can solve this, it's gonna be a big equation. Cubic. 3 more questions. 53. 53 says if a equals to this and b equals to this, then the value of a is 1 plus x square plus x cube. It's a GP. B is also GP. The value of 1 plus x bar y square x cube y cube. We are just multiplying these. A into b, 1 plus xy plus x power square. We just directly multiplied it. It won't be a into b directly because this is the sum. We don't know the value of a and b. We have to find it. And as this is the sum of infinite GP, so this will be equal to a upon 1 minus r. A is 1 and r is x. A upon 1 minus r, and this will equal to a upon 1 minus r. So a equals 1 upon 1 minus x. So x equals equals to a minus 1 equals to ax. So x equals a minus 1 upon a. And similarly, b equals 1 upon 1 minus y. So y equals b minus 1 upon b. So now we want this. This is also a GP with the first term 1 and the common difference xy. So we can put the value of x and y here and we'll get our answer. So 1 upon 1 minus a minus 1 upon a into b minus 1 upon b. AB will go at the top and here will be AB minus AB plus a plus b minus 1. AB upon a plus b minus 1. AB upon option B. If all the angles of a quadrilateral are in GP, find the angles and the common ratio and all the angles and the common ratio are natural numbers. Exactly two angles are acute and two are obtuse. The sum of angles in a quadrilateral A plus AR plus AR square plus AR cube equals to 360. All the angles and all the common ratio is a natural number. Exactly two angles are acute and two are obtuse. So we have to find the largest angle. We can take a common. So 360. Two angles are obtuse and two angles are acute. So these two are the smaller angles and these two are the bigger angles. The smaller angles will be acute obviously. So these are less than 90 degree. These are more than 90 degree. So we can guess we can guess A as something. We can guess A equals to 24. If A is 24, then D will be 2. Well, R will be 2, and A 24, 48, 96, 192. Largest angle will be 192. The sum to the 16 groups. Yeah, we can again solve it like the similar method. Use this. Then which term equals to 78? We have to find which term equals to 78. Okay. Come to the 16 groups. These are the sum of odd numbers. Sum of first n odd numbers is n square. So we just need to find sigma n square. Yeah. And sigma n square is we found it here. Sigma n square is this. So that will just be n plus 1 2n plus 1 upon 6, and we have to find for 16 groups. So we can just put n equals to 16 here. 16 into 17 into 33 upon 6. We get 1496. 1496. The sum of 16 terms of this series 1, 1, 3, 1, 3, 5, 1, 3. It's a similar question, but here we are told to find till the sum till 16 terms, not 16 groups. Here the 16 terms will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 7 it will be 1 plus 3 plus 5 plus 7 plus 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Till here it is 15. So 1 plus 4 plus 9 plus 16 plus 1. Yeah, so 9 plus 16 is 25. 25 plus 4 is 29. And 29 plus 56. 1, 1, 3, 1, 3, 5, 1, 3, 5, 7. 1, 3, 5. 1 plus 4 plus 9 plus 16. So, yeah, it should be 31. Sum of 16 terms of the series. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, 25 will also be there. 25 plus 1 because this is 25. So this is 56. Sum of n terms of the progression is 2n square plus 3, then which term equals to 78? Let's see what's the first term. 6. What is a1 plus a2? a1 plus a2 is 2 into 4, 8. 8 plus 3 is 11. So a2 is like 5. We have to just put the value. Let's see. mm, which term is equal to 78? A equals to Sn minus 1. So Sn is this 2n square plus 3 minus 2n minus 1 square plus 3. 2n square plus 3 minus 2n square plus 2 minus 4n. 6, 7, 8. 8 minus 4n. Yeah, equals to, want it equal to 78. So 4 minus 2n equals to 39. N square plus 1 minus 2n. N square plus 2 minus 4n. Oh, this will be minus 3. Sorry. This will be minus 3. So here it is minus 3. 3 cancels. 2 minus 4n. 2 minus 4n. So 4n equals to 76. N is around 19. Oh, and this will be plus. 4n minus 2. 4n is 80, n is 20. 20th term of this series will be 78. So we have done till 57. 4 questions are left.